What is string theory?
String theory is an attempt to reconcile Einstein's theory of general relativity, a theory of gravity, with the formalism of quantum mechanics and quantum field theory. So it is a consistent quantum theory of gravity. May not be the way that quantum gravity works in our universe, but at the very least, it's a theoretical playground where we get to ask questions about quantum gravity.
You've made an assumption in there, and I agree with this assumption, but I want to hear you defend it. You are trying to absorb Einstein's general theory of relativity, our modern understanding of gravity,
right,
into a quantum description. Why aren't you trying to take the quantum and absorb it into a general relativity description?
Because inherent in what both of you said, there must be an incongruency that would cause you to have to do that.
Exactly. So why don't you start with that, Laura? What is the incongruency here that you're trying to resolve?
Two of the greatest intellectual accomplishments of the 20th century, in my opinion, are Einstein's theory of gravity and the description of fundamental interactions in nature as described by particle physics. So things like a description of, quarks, fundamental particles, how they interact with each other, that gives us a description of things like electromagnetism and the strong and weak nuclear forces. These sort of basic building blocks of matter, these fundamental Legos that we can hook together, they're described very well by quantum field theory. The issue, the sort of discrepancy between these two, is that each separately are able to make predictions that are incredibly accurate in our modern world. So we can make predictions to like 13 significant figures using either of these theoretical frameworks.
That'd be 13 decimal places.
Right.
13 significant figures, yeah.
I'm going to say that's pretty accurate.
It's pretty great, yeah. And things like modern GPS wouldn't work without general relativity. So we have a lot of ways of testing these theories. They seem really robust and that they're telling us really important things about how the world behaves. Unfortunately, if you try and combine the two, so you try and describe phenomena that might need both tools. So for example, things where the interaction of particles and very short distance scales are in play, but also where there's really strong gravitation. So for example, inside a black hole, that would be a regime where you need both of these theories, these frameworks, to agree and give you concrete predictions. And unfortunately, the theories break down when you try and combine them, and you don't end up getting useful answers. You get very manifestly wrong answers. They're called disastrous infinities, things that just don't predict anything.
Wow, disastrous infinity.
Man, you can't get more dist than that.
Sounds like the worst marriage ever.
Yeah, it's not great.